us take up one more problem. How many gram of concentrated nitric acid solution should be used to prepare 250 ml of 2.0 molar HNO3? The concentrated acid is 70% HNO3. The given options are option A 45.0 gram concentrated HNO3, option B 90.0 gram concentrated HNO3, option C 70.0 gram concentrated HNO3 and option D as 50.0 gram concentrated HNO3. Dear students, the weight of HNO3 is given as molarity into molar mass into volume, that is in liters. So, this is the relation which satisfies all the data from the above question. So, let us write down the given data from the above question. Here we have 250 ml, that is volume of the solution, which is given as V, which is 250 ml. Since it is in liters, we need to convert into liters, therefore divided by 1000, which is nothing but 1/4 liter. Apart from that, we also have another data that it is 2.0 molar HNO3, that is the molarity is given as capital M and it is 2.0 molar. Therefore, we have in a given formula molarity and the volume, and only one which is missing is molecular mass, and let us find out the molecular mass. The molecular mass of HNO3 is nothing but 1 plus 14 plus 3 into 16, which is equal to 63 gram per mole. Now, let us find out the unknown parameter here. The molarity can be given as weight of HNO3 divided by molecular mass of HNO3 into volume of the solution in liter. So, let us substitute for that. Weight of HNO3 is two into 63 into 1/4 gram, which is equal to 31.5 gram. Therefore, the weight of HNO3 is 31.5 gram, but it is the weight of 100% HNO3. But what is mentioned in the question, it is 70% HNO3. Therefore, the weight of HNO3 can be calculated as 31.5 into 100 divided by 70 gram, which is equal to 45 gram. Therefore, the weight of given concentrated HNO3 is 45.0 gram, and hence the right option is option A. Let us move on to one more question. The normality of orthophosphoric acid having a purity of 70% by weight and specific gravity 1.54 is, the given options are option A 11 normal, B 22 normal, option C 33 normal and option D as 44 normal. Firstly, let us infer the data from the above question. So, here the solution is nothing but it is the orthophosphoric acid, and we all know that orthophosphoric acid is nothing but H3 PO4. And its purity is 70% by weight. It means that 70 gram of orthophosphoric acid is present in 100 gram of acid. So the next data is 70% by weight. It means that 70 gram of orthophosphoric acid is present in 100 gram of acid. And the specific gravity is 1.54. Specific gravity is nothing but the other name of density. Therefore, we have density as 1.54. Since the answers, that is the options, are mentioned in terms of unit of normality, we have to make use of normality for our calculation. And the normality formula is weight by equivalent weight into 1000 divided by volume of the solution. From the data, we have the weight of the solute as 70 gram into 1000 as it is, and we have to find out the equivalent weight and volume in cc. So, equivalent weight can be calculated as molar mass divided by its valency or number of replaceable hydrogen atom, because it is with respect to orthophosphoric acid. Since there are 3 replaceable hydrogen, the number of replaceable hydrogen is 3, and the molar mass of orthophosphoric acid is nothing but 98. I am substituting directly the value of molecular mass of orthophosphoric acid, because previously we have learnt how to calculate the molecular mass by considering the number of atom, multiplying that factor by atomic mass, and finally adding the values of all the elements, and that is how we obtain the molecular mass. So here I have directly substituted as 98 gram per mole, and the answer will retain as it is for the further simplification of the problem. So we have got the equivalent weight value as 98 by 3, and the only unknown parameter here is the volume, that can be calculated using the formula density is equal to mass by volume. So here only we will calculate. Volume is given as mass by density, which is nothing but 100 divided by 1.54. Here the volume is with respect to the solution, therefore m we have considered for the mass of the solution, which is 100, because 70% by weight means it is 70 gram in 100 gram of acid. So we have got equivalent weight, weight and volume. So let us substitute in the main equation and we obtain the answer. Therefore, the normality is equal to 70 into 1000 divided by equivalent weight as 98 by 3 into volume as 100 divided by 1.54. After the simplification, we obtain the normality as 33 normal. Therefore, the normality of the orthophosphoric acid is 33 normal, and hence the right option is option C. The next problem is the molarity of H2SO4 solution, which has a density of 1.84 gram per cc at 35 degrees Celsius and contains 98% by weight is, the given options are option A 1.84 molarity, option B 18.4 molar, option C 20.6 molar and option D as 24.5 molar. Now let us consider the given information from the above question. Here the given information is 1.84 gram per cc as a density. So the density is 1.84 gram per cc. And the another information is 98% by weight. That means 98% by mass means it is a weight percentage. So it is 98 gram of H2SO4 present in 100 gram of H2SO4 acid. Since the options are in terms of molarity and also in the question specifically they have asked to find out the molarity, so the unknown parameter here is the molarity and hence the question mark. The molarity formula is given as m is equal to the given weight of solute divided by the molecular mass of the solute into 1000 divided by volume in cc. And we have already got the weight, that is 98 gram, and the molecular mass of H2SO4 is also 98, and we already learnt that how to find out the molecular mass of given compound, and here it is H2SO4 and it is nothing but 2 into 1 plus 1 into 16, 1 into 32 plus 4 into 16, which is equal to 98 gram per mole into 1000 divided by volume. In order to calculate the volume, we have to make use of the given data density, and the relation is density is equal to mass by volume, and hence we can calculate the value of volume. So here is V is equal to mass by density, which is equal to 100 divided by 1.84. So this is the value of the volume. Now let us substitute all the data in the main equation. Thus the molarity will become 98 by 98 into 1000 into 1.84 divided by 100. So upon simplification, we get the molarity as 18.4 molar. The molarity of H2SO4 is 18.4 molar, and hence the right option is option B.
ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ನೀವು ದಿವಿಗೆ ಯೂಟ್ಯೂಬ್ ಚಾನಲ್ಗೆ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ಗೂ ಹೇಳಿ, ಇದೇ ಥರ ನೂರಾರು ವೀಡಿಯೋಸನ್ನು ಫ್ರೀಯಾಗಿ ನೋಡಿ.